check all of you download a lab manual for this experiment.
Yes, sir.
Okay, student, have you all got the lab manual for first experiment?
Yes, sir.
Yes, sir.
Here,
Okay, I am Professor M.K. Buria, your lab teacher. And if you
good
see the
afternoon,
mark, good afternoon. If you see the mark distribution for this lab, for this AC lab, so it will consist of 100 marks. Out of 100 marks, 60 marks. Let's discuss about first 60 marks. 20 mark is for your lab record. 20 mark for your internal viva. What do you mean by internal viva? After finishing each experiment, there will be 10 experiments. Okay, there will be 10 experiments. After finishing each experiment, so you have to give one internal viva of 2 marks. So when you complete 10 experiments, then total internal viva marks will be 20. Yes or no?
yes, sir. Yes, sir.
So lab record 20, internal viva 20. So it 40 marks has gone. Remaining 20 marks is 10 marks for your class performance, means how well you are performing the experiment, and another 10 mark is for your attendance. Okay. So this 60 marks distribution is well understood by you or not?
Yes, sir.
Okay. And the remaining 40 marks is for your final exam. In out of that 40 marks, 20 marks for lab experiment and 20 marks for your external viva, means final viva, the viva which will be taking place in the in that exam date. Okay. So this is how this 100 marks has been distributed. I hope it is clear to everybody.
Yes, sir.
Yes, sir.
Okay. So now today's experiment is all about getting familiarized with electronic components like a resistor, capacitor, inductor, transformer, ICs, and this is the very first and basic experiment, that is experiment number 1, that will be taught by our lab instructor. There will be 2 lab sirs, like lab instructors, Chinmay Das sir and Revati madam. They will be making you familiar with these electronic components, which is nothing but our experiment number 1. And then we will be sending you the list of the experiments that we are going to perform. Is it clear to everybody?
Yes, sir.
Excuse me, sir. Sir, do we need to write the experiment today? Because we don't have our lab file actually.
Lab record, you are talking about lab record.
Yes, sir. Lab record.
Lab file means which
Yes,
lab
sir.
file you require?
Lab
Sir,
file, that
practical
will submit
copy.
next week, no, not
Sir,
today.
like physics lab copy and chemistry lab record, we
That you
don't
have
have
to
now.
submit it
Yes,
next
sir.
week, not today.
Sir?
No, that you have to submit in the next week, but that okay, that we will discuss. Let the first experiment get finished, then we will discuss. Okay, how to write lab record and all.
Okay, sir.
Okay, Chinmay sir, you can carry on. You make them familiarized with these components, then we will proceed.
Yes, sir. Yes, sir. So, basically, in first experiment, it is the identification of different types of components, how to find out resistance value using color code method, how to use multimeter, and as this is an online mode, you have to be familiar with the software version of online version of that components, right? And which platform we are going to use, how it looks, how to use a multimeter in online mode or component, resistor, capacitor, etc. Okay, that this is the first experiment is familiarization of identification of different active and passive component, their symbol, color coding scheme, etc. Okay, so basically it's an introduction part, so no experiment is you are going to no circuit you are going to design in this experiment. Okay, second experiment also you have to find out the use of CRO and function generator. On third experiment onwards, we will start designing circuits. Okay, but this first and second experiment is very important because from experiment 3 to 10, you are going to use this knowledge of experiment 1 and the experiment 2. Okay, because you are going to use this component in future experiment, upcoming experiment. Okay, so all of you should listen carefully to this experiment. Okay, all of you downloaded the manual. All of
Yes.
you
Yes, sir.
Yes, sir. Yes,
must
sir.
download the manual, and I will advise make a separate file on your laptop, separate folder on your laptop for this lab, for every lab. Okay, and whatever document you are receiving, okay, and keep it there so that when required you can find out it easily. Okay.
So, can you please upload this file in Google Classroom also?
Yes, I can, but I am not in Google Classroom. Why I don't know. I'm not able to join
Okay,
Google.
okay, that will be done. That will be done.
Behavior sir will upload that.
Okay, sir.
Everything will be uploaded in Google Classroom, but okay. So I'm sharing my screen, and after explaining everything, if anyone is having any doubt, please feel free to ask immediately. No one is going to judge you. Okay. If you're having any kind of doubt, you should ask frankly. Okay. After that, otherwise, we'll start asking you questions. So, hmm, is my screen visible?
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
Okay. So, this is your experiment. Identification of different active and passive component. Okay. These are the example of passive components like resistor, capacitor, inductors, transformer. These are the passive components, and active component diode, transistor, ICs, etc. Okay. I won't go to the detail part. You have to go it over yourself. I will show you the. Okay. Now, first we'll discuss about passive components. Okay. Active and passive. Basically, electronic components are divided into two parts. One is active, one is passive component. So, passive component doesn't process the signal or amplify the signal. Okay, it doesn't have any self energy source. Where active component have its self energy source. It will be taught to you in theory class later in detail. Okay, so this is a carbon resistor. A passive. These are the passive components. One first is resistor. Okay. Resistor are also two types. One is fixed, one is variable resistor. By the name you can guess, in variable resistor we can change the resistance value. In fixed resistor we cannot change the resistance value. Okay. Similarly, your resistor, fixed resistor may be of different type depending upon what type of resistive material used. Okay. Suppose carbon is used as resistive material, so it will be called carbon resistor. Okay. Suppose a resistive wire is used here. This is a fixed resistor, so it will be called wire-wound resistor. Okay. So according to the resistive material used, its name has been changed. Okay. And this is a potentiometer or variable resistance. So you guys have seen these components before. This component particularly carbon resistor or fixed resistor anywhere.
Yes, sir. In some
Sir, in circuit
circuit.
boards.
Yes, sir.
It's
Circuit board.
this resistor is being used in everything. Okay. So this is a carbon composition resistor. There are some color codes on the body of the resistor. We'll go to that part later. Okay, today only. So this is a fixed resistor. Doesn't have any polarity. You can connect it at any terminal. Okay, and this is its symbol. Okay. Now this one. This is a potentiometer or variable resistance. Uh, Previously, it was used for volume controls and some voltage regulator. Nowadays, you guys are not being so acquainted with this, I think. Still, I hope some of you have seen this, use this. At least inside it may be have inside the equipment, but you have used it as for volume control like that. Okay. So this is a variable resistor. Okay. You can see it is having three terminals. Unlike fixed resistor, it is having three terminals. That means your midpoint will be a variable output. If you measure the resistance in between first and last point, you will get a fixed resistor. And from midpoint only you will get a variable resistor, and resistance value will change if you turn this knob. Okay, and you can see the symbol of the same, but one arrow mark is there for variable. Okay. This is a variable resistance. This is another kind of fixed resistor or wire wound resistor. Okay. So you might think that what is the difference between this fixed resistor and this fixed resistor? What is the need of designing another type of wire wound fixed resistor? Because the carbon resistor can be designed up to one several mega ohm resistance, but the wattage value power handling value may be maximum its wattage value up to 2 watt. Okay, but in wire wound resistor you cannot design a very high value resistance, because the more resistance value you need, the more length uh, of resistor wire you need. Okay, that's why its size will be increased. But you can design higher wattage rating of resistance using wire wound resistor. Okay, so any other example of variable resistance you guys have used in your school? Can anyone say any other kind of variable resistance?
Resistor.
Resistor, exactly.
Resistor.
If you remember the design of a rheostat, it will be easier to understand about variable resistance. Okay, in rheostat, from one end to beginning to end, there is a fixed resistor there, and in mid there is a tapping point. If you slide the tapping point, its resistance value increases or decreases. The more the resistive wire you are using, the more the resistance value you got. Same in case of this potentiometer also. Okay. Now this is seen this before. This is electrolyte capacitor, a fixed capacitor. Okay, and this is a ceramic capacitor. Okay. Same as resistor, this is fixed capacitor, this is a fixed capacitor. But electrolyte capacitor is having a fixed polarity, mean it is having a fixed positive and negative terminal, which has to be connected in the circuit accordingly. You cannot change its polarity while connecting in the circuit. Okay, but its capacitance value you can you can design higher capacitance value uh, capacitor using electrolyte capacitor, but in ceramic capacitor there is no polarity and capacitance value is generally low. Okay, so here also you can assume that depending on the dielectric material in a capacitor, charge is stored in dielectric material. So depending on the dielectric material, it is named accordingly. Okay, here ceramic is used as dielectric material, so ceramic, this is named as ceramic capacitor. Okay, so here it is electrolyte. So remember this, electrolyte have a fixed positive negative polarity, whereas ceramic capacitor doesn't have, but it's in low value. This is a variable capacitor or called gang capacitor. That means two capacitors are parallelly connected here. Okay. So it was used in radio frequency tuning previously. This is trimmer, another type of variable capacitor. The difference between this gang capacitor and this trimmer, both are variable capacitor. But gang capacitor, in this you can change its value any time. Okay, but this trimmer, usually trimmer is connected inside the circuit, so you can change its capacitance value, but it's a fixed variable type. I mean, you need a screwdriver to change its capacitor and set it to a particular value. Okay, so these are the symbol of variable capacitor, fixed capacitor. Now there is an iron core inductor. It's a coil only which passes DC through it and blocks AC. And this is a choke coil. This is another type of inductor. Okay. So in this iron core inductor mean the core is iron here. This is choke coil inductor. Here it may be a ferrite core or air core. Okay. And moving that core's position, you can vary inductance value. Acha. Now this is your transformer. Acha, how many points this inductor have? Only 2 points. You can see. Okay, one input, one output. Okay, but this transformer it is having 4 points. Okay, there is a step down transformer. So for transformer you need one input side, two terminal for input side, and two for secondary winding or output side. Okay. Suppose it's a step down transformer from 240 to 12 volt. So at one end will connect to 30 volt and out at the secondary winding will get 12 volt. Okay. So it looks similar but not same. Remember that. Till now anyone is having any doubt?
सर ये चोक कॉइल इंडक्टर का कैसे कंट्रोल करता है पर वो वापस बोलिएगा
ये इसका
यस सर
अच्छा नॉर्मली जो उसका दिस इंडक्टेंस वैल्यू डिपेंड्स okay the number of fluxes, the more number of turn, the more number of fluxes generates and the fluxes passes through that core. Okay, suppose in this iron core, that means the fluxes it will be more efficient and losses will be less. Okay, because the fluxes will be in a bound area for that core, iron core. Okay, so in this variable core, what will happen? There will be a core in between this, inside this, a vertical or cylindrical shape core. Suppose ferrite core. Okay. So as I said, core is responsible to hold that flux in that around. Okay. If you move out that core, okay, suppose halfway away, so what will happen that flux value will decrease and accordingly your inductance value will change. Okay, so is a variable inductor mean basically the inductor coil position is same. Here we are only changing the position of the core which is inside this. Okay, there is a screw type knob here. If you turn that clockwise or anti-clockwise, the position of core will go upwards or downwards.
Okay, sir.
Now, anyone else?
Can you explain that resistor part, both the resistor, carbon and other?
Carbon and wire on or
Yes.
variable resistor.
Sir, wire.
Wire on, no?
Yes,
Okay.
sir.
So as I said, carbon resistor and wire resistor both are fixed resistors. Okay, but in carbon resistor, the resistive material used as resistance is carbon granules. But from name you can guess. In wire resistor, the resistive material is a wire, is a resistive wire used as resistance. Okay. So, what is the difference? In carbon composition resistor, you can design higher value of resistance but low voltage. You cannot go up more than 2 watt. 2 watt is also very rare to see. Generally, we use 0.25 because if you change the wattage mean you understood? Wattage mean the higher the wattage value, it will consume more power, but it can uh, hold or handle more current. Okay, the more the wattage, more current it can handle or pass through it. Okay, so basically we use 0.25 or zero point 0.5 watt resistor, and it can be designed up to 2 watt max. If you increase the wattage value in carbon resistor, what will happen? Its size will be bulkier. You need more carbon granules and more space. Its size will be bulkier, and practically it is not possible to use in circuit. Nowadays, 2 watt is also not in use because it's bigger in size. Okay, the more wattage you need more bigger size. But compared to carbon granules, where in vacuum resistor we used wire as a resistive wire as a resistance. Okay, so this its current carrying capacity is higher than normal carbon granules. Okay, so it can design higher wattage resistance using vacuum resistor. But here again another demerit is there. But you cannot design higher value resistance using this because you need more length of wire, resistive wire, to get higher value of resistance. If you remember the example of rheostat, it's a from first end to last end, it's a fixed resistance. Okay, and in middle point there is a tapping point. The more you go to the right side or opposite, this more far you go from the beginning point, the more resistance you will get. That means what is happening? It's getting more length of resistive wire. Okay.
Sir,
Huh.
sir, I have a doubt. So in plus two, we studied R is equal to rho L by A. So here the length will only be applicable for wire wound resistor, but also for carbon also. If we increase the length for carbon resistor, will the resistance will increase?
Not
Okay,
exactly.
okay. Yeah, actually, resistance of any component equal to rho L by A. You can increase the resistance value any component by increasing the length or decreasing the
Uh,
decreasing the
Decreasing the area, decreasing the area.
effective area. Okay.
Yes, sir, effective area. Yes, sir.
Now the point is low watt resistor means suppose 2 watt resistor. If you give more power, that means for a particular value of resistance, you are trying to flow more current, yes or no? What is the
Yes, sir.
power dissipated in a resistor? That is I square into R, right?
Yes, sir.
So for a particular value of for a particular resistance value, if you increase the weightage, power weightage, then current has to increase, yes or no?
Yes, sir.
But the point is when you try to flow more current through a delicate
Why?
material or a delicate
Yes, sir.
resistor, that is going to melt. Okay. So the capacity depends on the material. How much current can it allow uh, to flow through it? From there only this power weightage is mentioned, that this component can bear up to this watt power. Is it clear to everybody? So
Yes, sir.
it is different. The difference lies in the component, the material by which they have been built up. In one case it is carbon, and in another case it is wire resistor. So basically difference in the material. All of you know when you are having two different material, the resistance value are also different. Yes or
Yes, sir.
no?
Resistivity will change.
Resistivity is different for different material. So this is how they are making different kind of resistors to support different level of voltage. Is it clear?
Yes, sir.
Okay.
Okay, so now we'll go for the active components. Like this is PN junction diode. Okay, I'll show this in Tinkercad. It's having a fixed anode and cathode terminal. Okay, it's a symbol. In symbol, this uh, line is there, and it's in triangular shape, and one line is there in this side. So that side is a cathode, and this side is a anode. In physical appearance, generally it looks black in color, black. Okay, and there will be a silver color band in one side. So that side terminal is your cathode, and the opposite one is your anode. Okay. So for Zenodide connection, if for forward bias connection, you have to connect anode to the positive side and cathode to the negative side. Okay. This is Zenodide. Here also there is a color band in its body, black color band. So that side terminal is your cathode and next side is your cathode. Anode, sorry. Anode. And this is a symbol of Zenodide. Maybe slight difference is there. Okay. I think all of you are getting confused by this different type of component, but no, don't worry. You are going to use this component in upcoming circuits. Okay. So it will be easier to you. 1 second. So this is PN junction diode and this is Zenode diode. And generally, we connect Zenode diode in reverse direction. This is a LED. I think all of you have seen this before. The symbol of LED. This is a transistor. It's a three-terminal component uh, consisting of emitter and base and collector. Okay, it may be of NPN transistor. It may be a PNP transistor. These things will be taught to you in theory class in detail. Okay, just see this is a transistor. This is another type of transistor, power transistor. Okay, and this is integrated circuit or IC. Okay, all of you have seen this before. Yes or no? Now, then after we'll go to
Yes, sir.
the color coding part of a resistor. Okay. Before that, I will show you this component on Tinkercad with the software we are going to use for designing circuit. So, Opal Google Tinkercad.com. Okay, click on this Tinkercad.com. I am sending the link in chat box.
Yeah, everybody should do along with the sir.
Acha. After going to the Tinkercad, I have already logged in. Logged in. Okay. You have to go to the right top corner and log in using your kit mail ID only. Because what in first we don't have any circuit designing, but afterwards your whatever circuit you will be designing in Tinkercad. Okay, it will be saved automatically through your mail ID, and later we will check your circuits. Okay, suppose experiment 5 is going on, we may ask you to show experiment 2, 3, 4's output. Okay, that will be automatically saved in Tinkercad in your profile. Okay, so that's why make sure that you are using your kit mail ID to for login in Tinkercad. Then after that, go to the circuits here. Okay, first one is 3D design, next one is circuits. Okay,
Sir,
then create a new circuit. Okay.
sir, it's asking for a password. It's saying that
Array, it is
already.
asking for making a password, not asking a password.
No need.
Making.
If you have
No.
opened your mail ID,
डायरेक्ट गूगल से लॉग इन कर लो
log in through Google. It will be easier. Okay, then click on create new circuit.
Sir, please wait to log in.
Okay.
So here we will draw the circuit.
But not today. Today you don't have any circuit. After login, just go to the circuit and create new circuit. Okay. We'll get this page. Okay. Uh, Here in right top corner, there's a component list. You can change it to basic, from basic to all. Okay. From all, you will get a large variety of components here. Okay. So I'm just showing the components here. Today we don't have any circuit design. The first one is a resistor.
Sir, can you
What?
again show? Can you go little back and show again, sir? Because we are logging in, sir. Didn't notice.
From the dashboard.
After coming the logging in, it will be initially it will be in this mode. Okay, go to the circuit here in left side. Okay, after clicking on circuit, click on create new circuit. Okay, for every experiment you need to create a new circuit one. Okay, and that will be automatically saved. Okay, you will get to this page, and in right side here's a list of components. Initially it will be in basic mode, change it to all mode. Okay, that's it. Okay, so how to use the components? Suppose this is register is here, you can see, all of you can see, just click, drag and drop. बहुत बड़ा register आ गया. And this is in vertical shape. How we will change this? Just click on, select the register or click on it and press R. You can turn it upside down or any direction you want. You can also change it from here. You can also rotate it from here. Okay. So this is a carbon composition resistor or fixed resistor, doesn't have any polarity, so only terminal 1 and terminal 2. By clicking on the resistor, its name, you can change its name, its resistance value from here, like it was in 1 kilo ohm value, I have changed it to 10 kilo ohm value. Here also you can change the range of the resistance. Okay, from 10 ohm or 10.
Sir, how to rotate it?
Click and press R.
Okay, sir.
Okay, press R, you can rotate it. Okay, now the next component is capacitor. I don't know why I'm getting this bigger size components. Okay, so this is a capacitor. This is also a capacitor. Okay, so this is a polarized capacitor or electrolyte capacitor, and this is non-polar capacitor, and it is generally ceramic capacitor. Okay, so as I have told earlier, this electrolyte capacitor is having a fixed terminal, positive and negative terminal. This one is negative, this one is a positive, but in this ceramic capacitor doesn't have any polarity. You can see only terminal 1, terminal 2, but it's positive and negative. You can see this white color mark in the body of the electrolyte capacitor.
Yes, sir.
Okay, so that side terminal is
Yes,
your
sir.
negative. In practical also, the electrolyte capacitor looks exactly same, and there is a body white color line or negative line marking on the body, and that below that a terminal will be there, and that is a negative of that capacitor. Okay. Similarly, here also you can change the capacitance value and voltage range from here. Capacitance and voltage range. Okay. Same for ceramic capacitor. Okay. Then This is inductor. Inductor doesn't have any polarity, so terminal 1 and terminal 2 and inductance value can be changed from here. 10 or 100 or 20, whatever you want, you can change the inductance value here. Okay. Then these are variable type of other components are also there. This is potentiometer. Okay. It is having a terminal 1, terminal 2 and wiper. Wiper means this is a variable output. Here also you can change in resistance value. So then what was the next component? Diode. LED, all of you know. LED for the diode. If you're not, if you don't find any component, you can directly type it here. Okay. This is a PN junction diode and this is a Zinor diode. Okay. I will just rotate it. Click and press R. So you can see in this Tinkercad, it looks similar, but practically this Zinor diode in crystal shape structure. Okay, on glass case. So or in blue cover case. Okay. So this is Zinor diode. This is PN junction diode. It is having a fixed anode and cathode terminal. Here, this one is cathode and this one is a cathode. And practically also the cathode side terminal, there will be a silver color mark on the body of the diode. Okay, so we have to consider that that side terminal is your cathode on. Okay.
Sir,
Huh.
sir, in potentiometer, the middle one is showing wiper. That means
Wiper mean what is happening normally this potentiometer how it is designed that there will be a carbon film. Okay, uh, from suppose this is terminal 1 and this is terminal 2, there will be a carbon film from terminal 1 to in round shape up to terminal 2. Okay, so if you measure in between these 2 points, you will get total resistance. This third point, this is connected with the wiper. Mean it just remember the rheostat connector part of the rheostat or midpoint of the rheostat. Okay, wiper mean it is moving. It will be moved on the top of that carbon film. Okay, more higher distance you covered in that carbon film, more higher resistance you will get. Suppose this wiper is at this position, that means in these 2 points we will get the resistance from this point to up to this point. Okay, the more length will you cover, the more resistance value will get, and this is in wiper shape. And in rheostat it is slider shape, slider position. Wiper, like in car wiper, it is placed on that top. So here also this variable point is placed on the top
like
of that.
to where we have to take that. That is.
So this one in potentiometer, the midpoint will be always variable output. Okay. Then what other components we left?
Sir, IC integrated circuit.
अरे ये इतना बड़ा है इसका, ये क्या हो रहा है इसको?
सर नहीं सर, एक्चुअल में वो अपने एक्चुअल साइज के हिसाब से आ रहा है सर, बड़ा छोटा नहीं हो रहा सर.
ठीक है. हाँ. So this is 9 volt battery. Okay, negative positive supply. I am deleting this. बहुत अजीब दिख रहा है. ठीक है. There are 1.5 volt batteries there. Variable voltage source is also there. Okay. And this is a operation. Oh, what is this? This is a IC. There are many type of ICs are there. This is a transistor. Okay, so these are the active components. Different type of ICs are there. Okay, can use whatever you want. Okay, so I see there's a dot mark here. White dot on that side terminal is a pin number 1. So in the software it is the which was the input, output or power that is directly written. But practically you have to remember for the IC number and a pin number, which pin is having input, which has to be connected in ground, that you have to remember. Okay. So pin number 1 to 4 you have to count from this. Opposite of 4 will be 5, then 6, 7, 8, 9. Okay. This is IC, this is a transistor, collector, base, emitter. Okay, 3 terminal transistor. Uh, Another important thing is this one. Okay. Acha, till now anyone having any doubt? Just drag and drop. I have showed you this things on your manual. Okay. We'll be using this component in upcoming experiments. Okay. Acha, this is an important thing. This is a multimeter. You guys have heard about voltmeter, ammeter.
Yes, sir.
So, okay, voltmeter has to be connected in parallel with the circuit. Ammeter has to be connected in series with the circuit, and ohm meter. Ohm meter is used to measure resistance. But a multimeter can be used as an ammeter or a voltmeter or the ohm meter. Okay, so it is having a fixed negative and positive terminal. If you click on this, okay, the name you can change, and mode. If you change it to amperage mode, that means now it's a ammeter only, and you can connect it in the circuit. You have to connect it in circuit in series and use it in any circuit. Okay. Similarly, you can change it to voltage by selecting voltage. Now it can be used as a voltmeter. Okay, and by selecting it in resistance, now it can be used as a ohm meter. Okay, this is a figure of practical multimeter. You can see here also. This is AC voltage, DC voltage. Some additions are there. Okay, this is for measuring diode. This is for current measurement. Okay, and this is for ohm symbol. This is for resistance measurement. This is a practical multimeter. Okay, and this is an analog multimeter. Nowadays, it is not being in use, but still you can see it in some electronic repairing shop. Okay, so that in Tinkercad we are going to use this multimeter. Okay, any doubt till now?
No, sir.
No, sir.
No, sir.
Okay. Now we'll go to the color code part of the resistor.
So this all we have to write in our lab manual.
Lab manual part, sir will tell you in detail how to write, what to write, what not to do. Okay, that will be told to you.
Sir, so we have to purchase a lab manual of physics or which subject of physics?
First, tell me what mean by letter.
Okay, sir.
After completing this to everything, we will discuss briefly about how to write the record, what type of record, where to write, where not to. Okay, everything we'll discuss.
Yes, sir.
Okay, actually, I will send you one sample copy for the experiment number 1. If you are getting if you will be confused, okay. So you can maintain that protocol or that systematic order for all the experiments.
Okay, sir. Thank you.
Okay. Okay. So all of you look at this table. This is a color code table for carbon composition resistor. Which means there will be color band. We have to find out its resistance value from that color band. Okay. So this is serial number 1. First one is a black. Second one is brown, red, orange, like that. And for every color there is a significant band. Okay, first band and second band are significant bands, 0, 1, 2, 3, 4 value. Okay, and your multiplier band. This is third. Generally, your third band is your multiplier band. Okay, and fourth one is your tolerance band. Okay, and this golden, silver, and no color. These three are tolerance band. So this is the example. Suppose here your first band color is brown. So what is the value for brown? 1, right? So directly write 1. Okay. And the second band color is black. So its value is 0. So directly write 0. Okay. Now third band is a multiplier band. So previously it was 1, 0, 10. So into third band color is suppose red. So its value is what? 10 power 2.
100, yes.
So in 10 into 10 power 2. So total it will be 1 kilo ohm, and fourth one is golden. Golden mean in golden you can see the tolerance value is plus or minus 5%. The silver is plus or minus 10%. So what is this tolerance band? That means the color code shows us the resistance value. So suppose we got 1 kilo ohm. So that is the manufacturer's code. Practically, we may got little fluctuated resistance like 101 kilo ohm, okay, or 98 kilo ohm like that. So this golden tolerance means plus or minus 5%. So the actual resistance may be vary up to plus or minus 5% of the actual value. And if your tolerance band is silver, that means your actual value may be vary up to 10%, plus or minus 10%. Okay. So if you are getting a 100 ohm resistance, that means practically you may got 92 or 110 ohm if your tolerance band is silver. Okay. And no color means there will be a color gap. There will be a gap or blank space. That means 20% tolerance is there. Okay. So which color band is better? That if you are having golden, that is more accurate resistance you have. Okay. I will show you one example. Suppose we'll zoom this part only.
So we have a trick that BB Roy of grade written on 11th or 12th for that bandwidth.
Achha, to remember that table.
Yes, sir. Table, sir. BB Roy of grade written something that.
BB Roy
On NCRT.
very good wife.
Yes, sir.
Has a very good wife, something like that.
Yes,
12th or
sir.
11th, I remember.
It was written in NCRT book.
NCRT, yes, sir. Written on NCRT book.
The black brown rods of your yellow gate became very good when given silver color.
So from beginning you can count it as 0, 1, 2, 3, 4 up to
Yes.
9. But as per my thing, that doesn't make any sense. Actually, the more you're using this, these things will be remembered automatically.
Yes.
But that is the trick, basic trick. You can use that also. BB Roy grade between very good wife. So if you don't have the table, so you can count and find out what is its significant band and multiplier band. So for green it is 5, and if your green is in multiplier band, that means it is 10 to the 5. Okay.
Yes, sir.
Now tell me it's how we'll find out its resistance value. First thing, this resistance doesn't have a polarity, so it may be in this side also. Okay, so first you have to find out which side is having your tolerance band. Okay, either it may be of golden color or silver color or no color. No color means there will be a gap.
Yes, sir.
So in this resistor it is a golden color. So this side is a tolerance band. That means we have to start counting from this side. Okay. Everyone got this? First you have to know from which side you have to start counting. Okay. So this is golden mean this is tolerance band. That means we are at last band. So this will be a first band. So this brown. For brown, what is the color code for significant value?
So one.
So brown it is 1. So directly write
Chinmasar, you can rotate the register so that
sir, I just rotated it to show them to find out the
no,
color.
no, that they understood. Now it will be okay.
Uh-huh.
Yeah.
Uh, so this is brown. Brown means 1. So directly write 1. Black for it is 0. So 1, 0. And for green it is
5.
5. So 10 to the power 5. So 1, 0 into 10 to the power 5. So what is the total value you are getting?
Array 10 multiplied by 10 to the power 5. How much you are getting?
10 to the power 6.
Yeah,
10 to the power
1
6, sir.
So 100 kilo ohm you are getting.
yeah,
So
1 mega ohm.
or 1 mega ohm. Sorry, 1 mega ohm. So if I'll change its resistance value, now what is its resistance value? Brown, black, and brown. 1, 0, and brown is 10 to the power 1. So total 100 ohm. Okay. The three colors are red. So it's
Any one of the student can find out the resistance value. Soham Patra, roll 831.
Yes, sir.
Tell the value, resistance value of this resistor. The first
Mm,
color is
red, sir.
red. So it is 2, right?
Yes, sir. Hmm.
Then again 2.
Again 2,
It
then
is
again hmm.
again 10 to the power 2.
10 to the power 2, again 10 to the
So
power.
22 multiplied by 10 to the power 2. That means
Yes, sir.
2200.
Yes, sir.
मतलब
2200.
2.2 kilo ohm.
Yes, sir.
2.2 kilo ohm. And what is the tolerance band here?
So 5%.
Plus or minus 5%. Why
Yes, sir.
tolerance is there? Because you see, when you are using resistor, so depending upon the operating temperature, all of you know resistance value depends on the operating temperature. Yes or no? अरे
Yes, sir.
टेम्परेचर चेंज होगा तो कोई भी कंपोनेंट का रेजिस्टेंस वैल्यू चेंज होता है कि नहीं? Because
Yes, sir.
every
Change.
component has some resistivity that depends on temperature. You know, conductor has when temperature increases, what happens to the resistance value of a conductor? अगर टेम्परेचर बढ़ता है तो कंडक्टर का रेजिस्टेंस वैल्यू क्या होता है?
Increases.
Increases. So positive resistivity, yes or no? And what
Yes.
happens to the semiconductor?
Decreases, sir. Ulta.
Decreases. Negative resistivity, yes or no?
Yes, sir.
So depending upon the temperature, working temperature or operating temperature, the resistance used in the circuit changes its resistance value. That is why we are having a tolerance band. Manufacturer has specified and that the resistance value can go up to this point to this point. Okay. Professor, you can carry on.
yes, sir. Yes, sir. Acha. So I think all of you got to know about color code part. Ma'am will give you some color code combination. You have to find out its resistance value. And for lab record, you can also take your own color code combination. Okay. Anyone having any doubt? Does anyone having any doubt on color code part or component part? No. All of
Can
you.
you again? Can you again? Uh, can you again calculate how to calculate this?
This color resistance value.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, let me show you again. Suppose this is a resistor having first color band is red, second is red, third is red. Okay. So for red, its significant value is 2 as per the table. Okay. So you have to write 2 directly. Okay. First significant band's value you have to write directly. First write 2. Second is also red, so directly write 2 again. So total is 22 till now. Okay. And third band is a multiplier band. So 22 into, what is the multiplier band value for red?
10 to the power 2.
10 to the power 2. Okay. So previously you have written 22 into, this is 10 to the power 2, 100. So total resistance value will go 2200 or 2.2 kilo. Okay. Let me check with another combination. Any other value you want to take?
Sir, third band is always a multiplier band, sir.
Yes, yes. But there is an exceptional case. Suppose if you need a value of.
Sir, what about no color band? Tolerance band when we have plus minus 20.
No, that you cannot change here. But if you don't have any color band here, okay,
Yes, sir. Yes, sir.
that means that is a no tolerance band. You are having no tolerance.
So
No
what
color
if you
band.
will get a color band there? For example, golden.
Sorry, I didn't get you. What if
We will get that tolerance band, sir. So gold.
gold means its tolerance value is plus or minus 5%.
Yes, sir.
So that means by calculating, suppose we get 2.2 kilo ohm resistance value. Okay.
Yes, sir.
Yes, sir.
Practically, if you measure it using a multimeter, practically it may not be exactly 2.2 kilo ohm. Okay.
Yes, sir.
The actual value may be fluctuate or vary, but up to what range? Up to plus or minus 5% of the calculated value.
Okay, sir.
So that is the tolerance now.
सर वो नो कलर, अगर कोई उसमें कलर नहीं रहेगा तो उसमें नो कलर बैंड का वैल्यू लिख देंगे.
हाँ, मतलब 20% tolerance value.
ओके सर.
Okay.
Yes, sir.
यस सर.
So I'll be taking the attendance now. All of you, just be prepared. Okay. Before I call your roll number, be prepared, and when I call your roll number, give your attendance. Okay, and turn off your mic then.
Okay, चिन्मय सर, तो फिर अटेंडेंस नहीं की तांको छाड़ दियंतु. So let's wind up today's experiment after taking attendance, and how to write that lab manual, that I will inform you. Okay, and I may be sending one sample copy of experiment number 1 that you can refer, and if it is required then I will tell you.
So
you
you have
will
to
print out
submit
the,
lab record in next lab. Well, today's experiment record, experiment 1's record.
Today's lab experiment means experiment
One.
lab record that they can submit within this week.
Sir, you will send us the lab example on WhatsApp or Google Classroom?
Yeah, that I will tell you.
Okay.
I may send in WhatsApp or Google Classroom. That you can refer.
And sir, the what to write and everything will be updated.
I think you have already done lab experiment in your first semester, right?
Sir,
What to write? Aim of the experiment. observation, aim of the experiment, equipment required, then your theory, then your observation. Theory, in the theory you can draw the circuit diagram, then what you have observed in the experiment, then after observation, then you have to write conclusion what you understood from this experiment. These the
That's the
five
whole
steps.
procedure.
Yeah. After theory, you draw the circuit diagram and write the procedure how you did everything, and then observation table, and then conclusion. This is the very means these are the steps that you maintain in all the labs, I think. Yes or
Yeah,
no?
sir. Yes, sir. Like we have
Sir,
maintained in
we
our
were not writing procedure in first semester.
So you send it, we will manage it. How?
Yes, sir.
Yeah. I will send one sample copy.
I will
Yes.
give them
Thank
a
you,
Okay,
sir.
sir.
little idea. You later you can share the detail on sample copy.
Okay.
Okay.
Yes, sir. Yes, sir.
Okay. So all of you attend your calls. Okay. First, roll number 742. This is 742, 744,
Yes, sir.
742 absent. अच्छा 745,
745 present, sir.
46, 47,
Present, sir.
48, 49,
Present, sir.
51,
Present, sir. Sir,
52.
48 present.
माइक ऑफ करके बोल रहे थे.
हाँ सर, मतलब ख्याल नहीं था, नेट स्लो था.
ठीक है, सब कोई रेडी रहो, लेट मत करो, ठीक है.
नहीं सर, एक्चुअली नेट थोड़ा स्लो था, इसलिए मतलब प्रॉब्लम हो रहा था.
सर 46 भी अभी था सर, वो डिस्कनेक्ट हो गया पता नहीं.
तो आपसे नहीं कंसीडर किया जाएगा.
Yes, sir.
51,
51 present, sir.
52,
Present, sir.
53,
Present, sir.
55,
Present, sir.
56,
Present, sir.
58,
Present, sir.
61,
Present, sir.
63,
Present, sir.
63.
Present, sir.
तुम लोग मतलब इतने बड़े ये हो, इतना बार बोलने के बाद, रिपीटेडली बोलने के बाद भी तुम लोग लेट करो. मैं
सर
बोल रहा
61 के बाद 62 सुनाई देता है, इसलिए वेट किया था सर.
ही रहो, ठीक है. मैं तुमको नहीं बोल रहा हूँ, उसके प्रीवियस वाले भी. तो सब रेडी रहो, प्रीवियस रोल नंबर तुम्हारा आने तक रेडी हो जाओ. अभी तुरंत कर दो, सो दैट कि बहुत जल्दी हो जाएगा. बहुत ज्यादा स्टूडेंट लिस्ट है तुम्हारा, बहुत लेट हो जाएगा. 64,
Present, sir.
65,
Present, sir.
67, 70,
Present, sir.
71,
Present, sir.
72,
Present, sir.
73.
Present, sir.
फिर से मैं बोल रहा हूँ, 1 सेकंड से लेट होगा, मैं आपसे नहीं कंसीडर करके नेक्स्ट रोल नंबर को जाऊंगा. 75,
Present, sir.
76,
Present, sir.
78,
Yes, sir.
79,
Present, sir.
80,
Present, sir.
83,
Yes, sir.
85,
Present, sir.
86,
Present, sir.
89,
Present, sir.
90,
Present, sir.
91,
Present, sir.
92,
Present, sir.
93, 93, 97,
Present, sir.
98, 99,
Present, sir.
801, 802,
Present, sir.
804,
Present, sir.
807,
Present, sir.
808,
Present, sir.
810,
Present, sir.
812, 11,
Present, sir.
812,
Present, sir.
814,
814 present, sir.
15,
Present, sir.
16,
Present, sir.
20, 817,
Present, sir.
19.
Sir, 818, sir. Sir, 818 present.
19.
Present, sir.
20. 21.
Present, sir.
22.
Present, sir.
23.
Present, sir.
4.
Present, sir.
25.
Present, sir.
27.
Present, sir.
28.
Present, sir.
29.
Present, sir.
30.
Present, sir.
31.
Present, sir.
32. 35. 35. 36.
Present, sir.
38.
Present, sir.
39.
Present, sir.
40.
Present, sir.
41.
Present, sir.
43. 48. 49.
Present, sir.
48. 51.
Present, sir.
52.
Present, sir.
53.
Present, sir.
54.
Present, sir.
55.
Present, sir.
53 तुम क्लास कर रहे हो बाहर घूम रहे हो?
सर क्लास कर रहा हूँ सर।
बैकग्राउंड में क्या लग रहा है कि क्रिकेट खेल रहे हो?
ना सर, मतलब मेरा घर मतलब रोड की साइड में ही है सर, मेन रोड में।
56. ओके ओके.
Yes, sir.
57.
प्रेजेंट सर।
59. 60.
Present, sir.
61.
Present, sir.
63. 63. 64.
Present, sir.
67.
Present, sir.
68.
Present, sir.
69.
Present, sir.
70.
Present, sir.
71.
प्रेजेंट सर।
72.
प्रेजेंट सर।
75. 75. 76.
Present, sir.
सर 7 and 8 प्रेजेंट सर, एक्चुअली डिस्कनेक्ट हो गया था।
7.
9 8
सर 767 भी सर माइक ऑन नहीं हो रहा था, स्क्रीनशॉट ग्रुप में डाले हम, चैट बॉक्स में भी लिखे थे।
798. हितेश. ओके. नेक्स्ट क्या बोलो? नेक्स्ट प्रॉब्लम
767
तुम्हारा क्या प्रॉब्लम हुआ था?
सर माइक ऑन नहीं हो रहा था, स्क्रीनशॉट सर ग्रुप में भी डाले हैं, चैट बॉक्स में लिखे थे।
ठीक है ठीक है. और कोई है? अच्छा, अभी तुम लोग क्या कर सकते हो, रिकॉर्ड तुमको जो मैनुअल मिला है ना उसमें पूरा फॉर्मेट में दिया गया है कैसे रिकॉर्ड मेंटेन करना है। फिजिक्स लैब रिकॉर्ड जैसे वन साइड रोलिंग रहता है, वन साइड प्लेन रहता है, सबको आइडिया है? ठीक है. और इसमें प्रोसीजर लिखना है. ठीक है, सब लैब में अलग अलग है, इसमें तुमको प्रोसीजर लिखना है. फर्स्ट एक्सपेरिमेंट फिलहाल तो कुछ प्रोसीजर नहीं है. ठीक है. So aim, equipment record, apparatus record, circuit diagram, or whatever diagram you have. Suppose in this experiment you have physical appearance diagram and symbol. Okay. So physical appearance diagram, that no need to be an artistic diagram. Okay. You can do it by your own.
पर वो डायग्राम हम वाइट साइड पेज में करेंगे ना, ब्लैक।
हाँ, yes. Diagram you have to draw in diagram symbol, that things you have a circuit. If you are having any circuit in any experiment, that has to be done in white side. Okay.
And sir, table in rules.
हाँ, yes. And at last is your conclusion. Conclusion that you have to write by your own. Okay. And from the more good your conclusion, it will be better to understand how you go, how did you go through this experiment.
Sir, we'll make a like a physics chemistry practical, like we'll make it, right?
Yes, one side plane, one side
Yes,
rolling.
Sir, this experiment one is divided into two
And,
parts, part A and part B. We have to write both or only part A?
Both, na? Multimeter part B, what is that? Multimeter, na?
Okay, sir. Okay, sir.
That you have to write also.
Okay, sir.
And anything else? Any doubt?
No.
Sir will share the sample copy. Okay.
We'll submit in
Okay, sir.
next class.
You have to we'll create an assignment. You have to submit it before next experiment on next Friday. Okay. So you guys have
Okay,
any
sir.
class on Saturdays or not?
Yes, sir. We have class
Yes, sir.
tomorrow.
We are
Wednesday
working.
timetable.
Wednesday timetable.
As per Wednesday timetable.
Yes, sir.
Sir, some teachers means that there is no official mail, sir. Tomorrow will be class there or no, sir?
Sir, we have theory class according to Wednesday timetable. If it happens,
That
we'll
was
have.
in previous semester, right? Or in this semester also?
This semester also, sir.
This
You got
semester.
in May this semester or you are following the previous semester?
Sir, in
But
the
it only states
Our-
that the class on 16th is going to happen on 19th. It
Yeah.
doesn't
Yes, sir.
state that all Saturdays are working for it.
Yes, sir.
no, actually, sir, there is a PDF in which we have date limit that when we will having end sem and mid sem. There there is a point that every Saturday will be a working day.
Yes,
Yes,
sir.
sir.
And today our BE
But
or
sir, no official mail is there.
previous
We aren't
previous
having
semester also
routine
there
for
was no
Saturday.
official mail.
Okay, no issue. That means it's working day because we got mail to as that Saturday is working day. That means you have to attend the class as per your timetable. Okay, Wednesday timetable. So next Saturday will be offside. I think Thursday. Okay, or it will be mentioned in a mail. Okay.
Yes, sir.
Yes, sir.
Okay, so you guys can leave. Thank you, sir.
Sir, please send us
Thank you,
the
sir.
example of that practical.
Yes, sir.
Thank you, sir.
Thank you, sir.
So,
Thank you, sir.
Thank you, sir.
Thank
Thank
you.
you, sir.